Hey folks, welcome back to Precalculus. We are in Chapter 1, Section 4 today, talking about complex numbers. Okay, so first let's start off with the complex number I, which we know is equal to the square root of -1. Okay, complex numbers have a real part, meaning a real number part, and an imaginary part. Okay, which is going to be the one that has the I in it. All right, the standard form for any complex number is either a plus bi or a minus bi. Okay, that's how we're going to write our complex numbers. So taking a look first at the first example here, we have the square root of -3 is the same as the square root of -1 times the square root of 3, which is I radical 3. Okay, because I is equal to square root of -1. All right, you can kind of say like, oh, I don't know the square root of 3, so since it's negative, I'm going to put an I in it, whatever floats your boat. Okay, so now moving forward, we know that this is -5 times the square root of -1 times the square root of 8. Okay, and 8 breaks into 4 and 2, and we know that the square root of 4 is 2. The 2 gets to come out, so we're going to end up with -10. Because that 2 came out with the -5, so it's -10 times I, and there's a 2 left inside. Okay, there's a 2 left inside. And moving forward, same type of question, same type of example, square root of -75. So it's the same as the square root of -1, which we know is going to be I, times the square root of 75, which is 25 times 3. Square root of 25 is 5, so we're going to end up with 5I radical 3. Okay, moving forward slightly, just a tiny bit more difficult question, but not crazy difficult. I'm just going to deal with this negative, or square root of -56 over here in the margin, and then kind of plop it back in and kind of see where that leaves us. So again, like we've been doing, that's square root of -1 times the square root of 56, okay, which square root of 56 we can break down into 8 and 7, which breaks down into 4 and 2, which breaks down into 2 and 2. So a 2 gets to come out, and a 14 is going to stay inside that 2 times 7. Okay, so this is really just 2 plus I times 2, radical 14, over 6. Okay, now, let's go down here where I got some space. Everything on the top is divisible by 2. We can pull a 2 out and everything on the bottom. So we can divide everything by 2. So this is going to become 1 plus I radical 14 over 3. And the proper way to write this number in standard form, just like we talked about up here, a plus bi or a minus bi is going to be 1/3 plus radical 14 over 3 times I. Okay, now we're going to slide down and we're going to take a look at addition and subtraction of complex numbers. It's just like terms. That's all it is. So I'm going to distribute my negative sign. So we got 13I minus 14 plus 7I. And remember that I want to write things in standard form, so I want my I to come second. So it's going to be -14, okay, and 13 and 7I becomes plus 20I. And there's your answer. Okay, over here, we can break these down over here if you'd like. So square root of -8 we know is going to be an I times something, so that's 4, 2, 2, 2, so 2 radical 2. So this is going to be -2 plus 2I radical 2 plus 5 minus, now we got to figure out what the square root of -50 is. There's going to be an I in there. Okay, so I'm just going to break apart the 25 and the 2. So the 5 is going to come out. It's going to become 5 radical 2. So 5I radical 2 And now it's just a matter of combining like terms. We have a negative 2 plus 5, that's going to be a 3. We got a 2i radical 2 minus a 5i radical 2, those are like terms. So we end up with negative 3i radical 2. Okay, easy peasy. Now we're going to go ahead and talk about multiplying complex numbers, and aka we're going to be using the distributive property. The distributive property. All right, we're just going to be distributing things in. Okay, so square root of negative 5 times the square root of negative 10. So that's going to be I radical 5 times I radical 10. Okay, now I times I squared, 5 times 10, 50, which we already did up here. You guys know that. You guys know what the square root of 50 is. It's going to be 5 radical 2. So I squared is negative 1 times 5 radical 2. Super simple. Okay, so now looking at the next one. So we've got square root of negative 2. That's going to be I radical 2 times 3 plus I radical 7. Distribute this bad boy in there. So we've got 3I radical 2. Now I squared radical 14. Now we know I squared is negative 1, so this I is going to kind of disappear. And to put it in standard form, I'm going to put it first. So the negative radical 14 is going to appear first, plus the 3I radical 2. So it's in standard form. There you go. Okay. Lastly here, you're going to kind of a little bit of foreshadowing. We're going to be multiplying complex conjugates. And we know when you multiply any conjugates, you should get difference of squares. I'm going to go ahead and FOIL the whole thing out so you guys can see it. But here we go. So 6 times 6, 36. 6 times 2i is 12i. Negative 2i times 6 is negative 12i. You can see those are getting ready to cancel out. That's nice. And negative 2i times positive 2i is going to be negative 4i squared. Okay, which we know is 4 times negative 1. So this becomes 36 plus 4, which is 40, which is really cool. We're about to see here in a second that multiplying any complex conjugates always is going to yield a real number. Okay, so now in the back there, when two complex numbers are multiplied together and the result is a real number, these two numbers are called complex conjugates. Complex conjugates. We just did this. We just did this in example 9. Okay, we say multiplying a plus bi times a minus bi. Those are complex conjugates. It's going to be difference of squares, and it's going to be a real number. Okay, so super cool to realize, learn, and utilize. We're going to utilize that in a little bit. Okay, but first, let's talk about the higher powers of I. Okay, we know that I squared equals negative 1. Okay, so if I squared equals negative 1, then I cubed is equal to I squared times I, which is negative 1 times I, which is negative I. Okay, and I to the fourth is equal to I squared times I squared, which is negative 1 times negative 1, which is 1. Okay, and you'll notice that I'll do I to the fifth first before I say this, but I to the fifth is the same as I to the fourth times I. We know that I to the fourth is 1. 1 times I is I. Okay, so the powers of I are cyclic. Therefore, we can reduce higher powers of I by dividing the exponent by 4 and looking at the remainder. Okay, because it's always going to go I squared, I cubed, I fourth, and then start over. I squared, I cubed, I fourth. I squared, I cubed, I fourth, and so on and so forth, no matter what the power of I is. Okay, so if we take a look at I to the 50th power, okay, let's just take 50 and divide it by 4. And we'll do some old school multiplication here. Okay, that's going to be equal to 12 with remainder of 2. Okay, so I to the 50th is the same, that's a 50, sorry guys, is the same as I to the 48th times I squared. Common bases, you would add together your exponents, you get I to the 50th. And this is a perfect cyclic of 4. Okay, so we know that this right here is going to be 1. So we got 1 times, well, what is I squared? I squared is negative 1. So 1 times negative 1 is negative 1. Okay, so let's dive into the last step here, the last part of the notes, and that's talking about dividing of complex numbers. So since I is equal to the square root of negative 1, having complex numbers in the denominator is like having a radical in the denominator. So we treat them the same way and rationalize by using the complex conjugate. Using the complex conjugate. Okay, so if we look at this, if we look at this example right here, we know that, oh, we have a square root in the bottom, but it's 36. We know what the square root of 36 is, but it's negative. So this is actually negative 5 over 6i. Okay, and we talked about it. Having an I in the denominator is like having a radical in the denominator. We want to get the radical out of the denominator, so let's multiply by I. Okay, we know that if we multiply I times I, we're going to get I squared, which is a real number, negative 1. Okay, but whatever you do to the bottom, you got to do to the top, multiplicative identity time. So we're going to end up with negative 5i on top over 6i squared. You know that I squared is negative 1. It's going to cancel out that negative right there. So we're going to end up with 5i over 6 as our final answer, or 5/6 of an I, if you'd like to say it that way. Okay, so let's jump over into the next example, example 12. And we notice that we have, again, a radical in the denominator, an I, an imaginary I. So we're going to have to multiply by something to get rid of it. And we just saw in example 9, I encourage you to look back at example 9. If we multiply by the complex conjugate, it's going to be a real number, meaning it's going to have a real number in the denominator, no imaginaries, no radicals, boom. So let's go ahead and multiply by 4 plus 5i. Okay, whatever you do to the bottom, you've got to do to the top, multiplicative identity. Okay, so if we take a look at the top real quick, distributing a 2 in there is relatively easy. 8 plus 10i. Okay, now looking at the bottom, we know we're going to get difference of squares. Okay, we know we're going to get difference of squares, but let's take a look at what's going to happen here. We're going to end up with 16 and 25i squared. We know I squared is negative 1. It's going to change that to addition. We're going to end up with 8 plus 10i over 16 plus 25. Because that I squared is negative 1. Canceling out that negative, making an addition. 16 plus 25 is 41. Rewriting this in standard form is 8 over 41 plus 10 over 41i. Okay, now the last page of the notes are all examples like we've just done. Okay, so you will need your notes previously to go ahead and do all of these examples. But I want you to do all of them on your own, bring them to class, ask questions if you have any questions. Obviously, I'll have more examples for us to do, and I can help you with anything you need help with. So make sure you try all of them, and I look forward to helping you guys in class.